This oil spill is not over. It will be decades, I think, before we really understand the true impacts of the spill on the system.
This is a massive amount of oil. 4 million barrels is what the Oil Spill Commission report said was spilled into the Gulf. Much of this rung around the Gulf, as you see here. Some of it evaporated, some was degraded, but of course, a large amount came onshore and came in contact with coastal wetlands.
The undersea plume story broke on May 16th or thereabouts and caused quite a discussion. If you go above or below the plume, you have very low concentrations of total petroleum hydrocarbons. You have low concentrations of PAHs and alkanes. All of these things are derived from the crude oil spewing out of the wellhead. If you go into the plumes, however, you see very, very elevated concentrations of total petroleum hydrocarbons and PAHs, polycyclic aromatic hydrocarbons, and alkanes, which also come out of the oil. And these levels of PAH are toxic to organisms. The other thing that was really fascinating and interesting about these undersea plumes is the fact that they were essentially loaded, just laden with dissolved gases. The gas concentrations in these plume cores were up to 400 micromolar. That might not sound like a lot, it might not mean a lot, but to put it in perspective, the general concentrations that you see in the Gulf of Mexico are 75,000 times lower than that. So these are quite high concentrations of gases in these plumes. I got a lot of flack for talking about oil on the seafloor. Nobody really believed that it was there, or said that it was from, other places. It wasn't from the wellhead, it was just from other places. Every single station that we have sampled has had, within 80 miles of the wellhead, if you sort of put the wellhead in the middle and go 40 miles in either direction, every single station we've sampled has had this very strange layer, which I've never seen before in all the collections I've done in the Gulf of Mexico. And they contain variable amounts of oil and PAH and alkanes, heavily weathered and biodegraded, but nonetheless, these PAH levels are toxic in some places. We all saw the same thing and we were all like, holy cow, it's everywhere. And you can smell it, you can see it, it's like you would have to be deaf, dumb, and blind to not say, wow, this is an impact.
We have evidence that there was a mass mortality of pteropods in the Gulf of Mexico, likely associated with this oil spill.
There was a mass mortality of pteropods, and these pteropods are essential components of the zooplankton in the Gulf of Mexico. And we don't know what will happen if you just kill off an essential part of the food chain, which we've apparently done in the course of this oil spill.
We have preliminary evidence, and we're doing the chemical workups now, that in fact this oil spill event is associated with a dramatic flux of organic matter, dramatic flux of organisms to the bottom, with implications for the food web that'll take years to play out and which we're only now beginning to try to understand.
From my perspective, we have long data sets, historical data sets of zooplankton, and as Joe just mentioned, the zooplankton are this very important component of the system, and the very nature of this oil spill likely had large implications for what happened to those zooplankton. And the zooplankton in turn are very important. Everybody knows the Gulf of Mexico is a highly productive system that generates a very large portion of our nation's seafood supply. So we believe there was an impact. Now the question is how pervasive was that impact? Is it something that we might expect to go on in time? And those are very important questions that we're working on now.
About 419 miles total of marsh shoreline were oil. That's the estimated oil edge official. And that's out of 7,700 miles of shoreline. Even though that's not insignificant, that's only about 5% of the Louisiana coast. So we were lucky in that respect, in that sense. The impact to some of these marshes was severe. Luckily, amazingly, actually, Oil only affected the marsh shorelines, not the interior of the marshes. We are starting to see some recovery. I would not say it's extensive at the moment. We are seeing some. One of the things we don't know is how much recovery will occur in these oil shorelines that you can see here. We'll find out, I think, this spring and summer.
In July, we went out with an ROV for NERDA and dove on 4 of the sites that were abundant, lush communities that were fairly close to the Macondo well. What we found were healthy, apparently healthy communities. No obvious visual signs of impact. Fish, corals, associates all appeared to be doing quite well. But the real discovery was that red arrow, which was a site which we chose because it was the same depth as the Deepwater Horizon spill. It was the direction away from the spill where the empirical data and the models said a deep water plume traveled, and it was the closest site in that we knew of. And unfortunately, when we dove there, what we found was a very heavily impacted community of corals, covered with a brown material, very sickly looking associates attached to them. Are there sublethal effects not yet detected? We went to a lot of beautiful places where they appeared to be doing fine. However, that's just a quick look. We don't know whether their food source has been knocked out. We don't know whether the reproductive potential has been impaired. Think about how long it takes for cancer to appear in a population that's been exposed to toxins. It could be a long time before we know the full effects of this spill. So we don't want to just dismiss the sites that look good. We need to go back and keep an eye on them.
Not always directly, but often indirectly, sometimes through the press. Those of us in the academic community who were working in the Gulf, finding things and wanting to share our results, felt that there was resistance to our data, to our interpretations. You can often look at these things and with a very high degree of certainty tell what's happened. So there was often this roundabout communication, this roundabout, what we perceived as pushback from agency scientists who, for reasons I don't fully understand, were often reluctant to accept at face value our preliminary data, our preliminary interpretations.
I don't understand why there was this tremendous pushback to sort of rein it in and tone it down, and I don't think any of us really toned it up. We just reported what we saw. We felt that it was necessary to get the word out there because these plumes weren't being tracked, they weren't being studied, they weren't being followed.
When you've got an event like this that the public is so interested in, and it has the financial, the economic, the societal implications of this, I think it's incumbent upon us to release the information as quickly as we can.
You know, some things you can see and you know it's anomalous, and you report it and you talk about it to the press. We did it so that NOAA would be aware of it and to sort of hopefully push more research focus on these features, period. I've never gotten a phone call from NOAA asking my opinion or advice about anything. And I still find that kind of shocking. Ian McDonald, who's worked in the Gulf for years, you know, Vernon Asper. It's just, you just sit back and you wonder, well, if you're going to criticize me, let's talk and figure something out.
Scientists, because of who we are, we trust each other. And, you know, we trust that whether or not you get the answer that you thought you were going to get out of the question that you asked, at least I can trust that you collected the data and reported the data in an honest fashion. And so what you saw is what you saw.
I would add, I think one of the big mistakes that was made is that the government did not reach out to academia early on.
If this ever does happen again, the first recommendation I would make, if anyone would listen, is put together a panel of experts who know the system, whatever system it is.